Okay, your first pre-lesson. This is Pre-Calc B, second trimester, lesson 1, 2. And the title of it is Functions and Their Properties. Now really, the meat and potatoes is the word domain. Now they're going to talk about domain and range, but I'm going to kind of put a little, it's more of a precise thing about domain. So let's just dive in and talk the talk. You guys ready? So, your last lesson, if you were listening to my packet lesson, I talked about domain range. Domain is your x values, which means how far left do you go? Wait a minute, I was going backwards. Is that your left? Anyways, domain, how far left do you go? How far to the right do you go? Range, how low do you go? How high do you go? Hopefully you got that tucked away. So, if I have an equation like this, and I said, okay, let's graph it, I'd plug all these in, so that'd be negative 6 plus 1 is negative 5, that'd be negative 2, negative 4 plus 1 is negative 3, negative 1, that'd be negative 1, and I can kind of see a pattern. See they're increasing by 2, so that'd be 1, that'd be 3, that'd be 5, that'd be 7, whatever. So technically, for this equation slash function, see, as soon as you start going f of x equals 2x plus 1, you guys think of this as a function, and you think of this as an equation. They're both equations, and they're both functions. So let's get that out of the way. But what's my domain? It's my list of my x's. See, this is different, slightly different. This right here would be referred to as my domain. This right here would be referred to as my range. Now I'm just going to plot a couple of them, 0, 1, and then 1, 3. I'll just go 1, 3. And I'll just connect the dots. Now what about these other coordinate points? Well, they're along here. But if I said, what's the domain of this graph? You'd say, oh, how far left does it go? Negative infinity. How far right does it go? Infinity. What's the range? Well, how low does it go? Negative infinity. How high does it go? Infinity. All right. So if I have something like this, and it says, what's the domain? I list these elements. If I have something like this, and it says, what's the range? I list these elements. But if I have a graph, I have to think of the whole graph, and this would be my domain, this would be my range. A little confusing. Just depends on what the given information is. Now we're going to actually take it to a different direction. I have to start with just talking to you about some math no-nos. These are things in math you just kind of carry in your back pocket everywhere you go, every problem you approach. There are some things that cannot happen in math. Now what's 10 divided by 2? 5. Now let's test that. What's 2 times 5? 10. So you're like, duh, hold on. What's 0 divided by 2? 0. Test it. What's 2 times 0? 0. You're like, okay, let's go to this next one. 2 divided by 0. If I turn this into like a first one to answer it correctly gets some prize, I bet you a few people would say 0. What's 2 divided by 0? How many times can you fit 0 into something? Well, this is mathematically impossible, but let's say somebody said, let's see if it's 0. That would mean 0 times 0 is 2. Is there any number I could put here? And 0 times whatever number this is would give me a 2? Never. This is never possible. You can't have a 0 in the denom. Now, an extra clue. It's okay to have a 0 in the numerator. So what's the only no-no? Having a 0 in the denominator. Now let's take this idea and apply it to this problem. It's saying find the domain. Well, we have to look for the math no-no. So we say, okay, wait a minute, denominator, that's what's dangerous. I can't have a 0 down there. So I would look at this and I'd say, aha, x cannot equal 2. Now you guys have to listen to me very carefully. Back in Algebra 2, we'd be done. We'd say, okay, x can't equal 2. Good job. Pat on the back. You get it correct, move on. In pre-calc, the language changes a little bit because if we look at a number line and we say, there's my 0, There's my 2. This is the only thing that x can't be. I'd go open circle, and then I'd say, okay, x can be everything to the left and everything to the right. Now that's a visual image of the pre-calc/trig answer. How do we say this? We say it by saying, aha, my domain, remember it's my x's? It can go it's going to go to the left of 2, so it's going to go all the way to negative infinity, all the way up to 2, but wait, does it grab 2? No. 2 is mathematically impossible, so we put parentheses around it. If I did this, if I put a bracket right there, I'd be saying, oh yeah, and x can be 2 also. No, x can't be 2. But then you have to say, but there's another piece. See, this is piece number 1. This is piece number 2. Now I have to explain this. So I put that little upside, well, it's a U. That means union, together with. And then we say from 2, see parentheses, very significant, all the way up to infinity. Algebra 2 is a lot easier. You just talk about what x can't be, you're done. Now you've got to talk about what x can't be to figure out what x can be, and it just adds a little work, okay? So, let's move on to, oh, I forgot something. Let me throw in, what if I had x plus 3? See, takes a little while to get used to this, but what's the only fraction no-no? Can't have a 0 in the denominator. So if somebody starts focusing on that x up there, they're in trouble. Because here's a weird thing in math. It's okay to have a 0 up here. So if I looked at this for a second and I'm like, oh, x can't equal negative 3, you'd be wrong. X can equal negative 3 because you can have a 0 in the numerator. So guess what? You ignore the numerator. By the way, throw this one in for free also. What is f of x equal to? Well, that equals y. What's y? Y is my range. What's this problem asking for? Domain. So I can ignore the top. I can ignore this because it's asking for the domain, which concentrates on my x in the denominator. I know that's a lot, but I hope that made sense. Let's go on to this guy. Mathematical no-no. Square root of negative 49. I know in algebra 2 you're like, oh, that's 7i. But what's that I stand for? Imaginary number. It's not a real number. So mathematically, that's impossible. So what about the square root of 49? Well, just thinking about the positive root, we'd say 7. By the way, negative 7 works too, you know, but we're just talking about the positive one. How about the square root of 19? Well, it's not a nice, perfect root, but I'm just guessing. What's the square root of 16? 4. So what's the square root of 25? 5. So it's somewhere in between there. Let's just go 4.3. I'm just guessing. I can get a calculator out. All I'm saying is, these are okay. This is not okay. In other words, you cannot have a negative underneath the square root. How do I apply that to these problems? I look at this. I think to myself, what's it asking for? It's saying find the domain. What's that mean? Concentrate on your x's. What's that mean? Ignore g of x. What's g of x? Well, it equals y, so I can ignore that. What's the problem here? The problem is this stuff cannot be negative. Well, how do I say that mathematically? Well, I can't say it directly, but what's a different way of saying it? Well, let me also throw this one at you. Square root of 0. What's the square root of 0? 0. So instead of talking about what this can't be, let's talk about what it can be. It can be 0 or anything positive. So if I look at this on a number line, I'm saying this stuff can equal 0, so I'm going to fill that in, and anything to the right. How do I say that mathematically? Here it comes. 2x plus 1 can be greater than or equal to 0. So Mr. Cleafish, whenever I get these square roots, I can just take whatever's underneath there and set it greater than or equal to 0? Exactly, because you're saying this stuff can be 0, but it can also be something positive, greater than 0. And then I just solve it. Negative 1, negative 1. 2x is greater than or equal to negative 1. Divide by 2, divide by 2. Don't forget, if you ever multiply or divide by a negative in an inequality, you got to flip the inequality. So what do I get? I get x is greater than or equal to negative 1/2. Now, this is my answer. So pick something greater than negative 1/2. Okay, 0. Plug it back in. What's 2 times 0? 0. 0 plus 1? 1. What's the square root of 1? I don't really care what the answer is. I just care that it's mathematically possible. That's all that this is kind of talking about. Now pick something not greater than negative 1/2. Okay, negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. I get the square root of negative 3, which is a no-no. And so it looks like I've honed in on the answer for the domain for this problem. All right, now I'm going to solidify that with a few sample problems from your packet.